All right, we are recording. And Chris, I think I'll let you introduce yourself if that's all right.
Yep.
Okay, take it away. It's all yours.
Hey, great. Hi, everyone. I'm Chris Halcrow. I'm a research software engineer in the Nolan Lab at Edinburgh, and I spend about half my time developing Spike Interface, which I'll tell you about. Now, I'm going to tell you quite a lot of things about Spike Interface, so I've made a little resources page that has lots of links about the things I'm talking about. You can't take what I'm going to say in 20 minutes, so the link is there. Please go to it and check the links there. Okay, so part of my job is developing Spike interface, but part of it is using it to apply spike sorting to eFIS data. And eFIS data comes in all shapes and sizes, tetrodes, silicon probes like NeuroPixels or Cambridge Neurotech, and then higher density probes, including in vitro ones that go up to like 4,000 channels in a 2D planar array. And if you're at this conference, you probably love eFIS data, but you probably don't love spike sorting it. So spike sorting is the process of taking your data, looking for spikes, clustering them into units. Each unit is meant to represent a single neuron, and you get all the spike times in each unit, and that's what comes out. And I think you guys have already seen a pipeline where you take in maybe OpenEFIS or Spike GLX data, you sort it using HeloSort 4, and you look at the output using Phi. But there is not just the recording formats OpenEFIS and Spike GLX. There are loads of recording formats. There's not just KiloSort. There are loads and loads of sorters, and even each sorter version has many subversions in it. And Phi is not the only output. There are loads and loads and loads of sorting outputs. And this is a big problem. It's kind of overwhelming how many combinations that there are. And the basic questions are, I mean, just taking each of these, how do you open all of these different formats? How do you run all these different sorters? Once you have output, how do you visualize them? How do you compare them and put them on an equal footing? And then also, if a postdoc ran a sorter and did some recordings 5 years ago, and you go and look at that data, how can you still look at it? Or how do you ensure that the stuff that you're doing right now can still be read in 5 years' time? So, an overwhelming problem, but good news, there is a solution. And the solution is Spike Interface. So Spike Interface is a Python package, and the idea is that we can take in any of these raw data formats, and then we kind of wrangle them and smush them into a nice recording format. That's made so that we then wrap any of these spike sorters, and they can take in any of those objects, and then they spit out a sorting, and we can output those sortings into any of these different formats, or we can load in those sortings again. So the idea is to kind of abstract everything away, and then similar to, you've probably seen the output from Phi, which combines the recording and the sorting and has some post-processing things like spike units and waveforms and things. We also have a standardized format for post-processing, and that also has full provenance. And full provenance means if you find a sorting analyzer, it contains all the information within it that you can recreate it from raw data. So that's the kind of big picture. So the issues that Spike Interface is trying to solve is all these different file formats that exist and all their different ISO, all their different interesting incompatibilities and things. We try and standardize that. We try and solve the problem that spike sorting can be difficult by wrapping all the spike sorters and giving a kind of unified interface for using them. And we try and solve like the problem of a lack of data provenance in eFIS in general by making, if you export a recording or a sorting or this combined sorting analyzer, we save all the provenance that says what's been going on with those things. Okay, so now I'm going to show you how Spike Interface works. And usually you'd start at the start of this pipeline and show how to get to the end. Instead, I'm actually going to show you the end product to convince you that it's worth investing some time in learning about Spike Interface. So we're going to look at this sorting analyzer, which is the endpoint of your pipeline. So the sorting analyzer, it contains all the things you'd be interested in: spike locations, templates, correlograms, quality metrics. And the idea is it's a standard format, and you can take in any sorting information, blah, blah, blah. And then the hope is that this is a standard place that other people can build tools on top of. So I'm going to show you all of those tools as a kind of advertising wheeze. So first of all, there's something called Spike Interface GUI, which is meant to be a bit like a phi replacement. But the advantage of this is it works, with all sorters, whereas phi only works with kilosort. So it's a little GUI that allows you to look through units. You can rearrange it if you really like looking at waveforms, like I do. I can do that and take a look, have a look at a couple at once. If I'm paying attention, and so on and so forth. So there are tools to visualize based on the sorting analyzer, or you can just read in the sorting analyzer using Spike Interface and do things like plot little unit summaries. Sorry, there's some zoom controls in my way, so I'm just going to move them. And from the sorting analyzer, you can get things like spike trains telling you all the spike times of this unit. There's also other tools, such as something called Unit Refine that I'll talk about later. What this is doing is using some machine learning model to try and predict the quality, try and predict whether the units that we're seeing are noise or good units. So for instance, this is saying that unit 3 is definitely noise, but unit 372 is a SUA. So, sorry, single unit activity. So let's have a look at claimed this was noise. Yeah, that looks a bit like noise. It said this was a single unit. Yeah, that looks like a bit of a single unit. Also, other tools use the analyzer as well. So NeuroConv is a tool for making NWB files, and it has a function which is write a sorting analyzer to an NWB file. So if I run this, that's going to create a file that's ready to go on Dandy for you. So I hope you're now convinced that you want to make a sorting analyzer because all these different tools use it. Also, unit match has its Python script is based on analyzers, which does matching between recordings. And also there's some sorter comparison tools such as Lusac and some internal tools. So now I hope you're convinced you want a sorting analyzer. And your question is, but Chris, how can I make a sorting analyzer? Well, it's pretty straightforward. Here is a basic Python script that'll get you a reasonable sorting analyzer. You import, this is like a Python script. You import Spike Interface, read in your OpenEFIS recording, do some pre-processing, run a sorter, create a sorting analyzer, and then compute some of these extensions. That's it. But what if you want to use mountain sort instead of kilo sort? That's all you need to change, no problem. How about if your lab goes from using OpenEFIS to using Spike GLX? No problem. I also want to compute the spike locations. You can add them in. I've forgotten to do bandpass filtering. One extra step. How about if you do a NeuroPixel recording on 4 shanks and you want to run the sorter shank by shank instead of all at once? All you need to do is add a split by group. In a couple of weeks' time, once we've added that feature, it'll be there. How about if you've got 2 recordings and you want to concatenate them and sort them together? Well, you just read in 2 recordings, you concatenate them, and you're good. You might have heard a lot about motion correction. How do you do that? Well, it's just another pre-processing step. That's it. So I'm hoping what I'm trying to convince you of is once you know the API a little bit, Spike Interface will make spike sorting easy with any file format that you choose, any pre-processing you want to apply, and any spike sorter that you want to use. Then at the end of it, it spits out a standardized object that you can share and reproduce between labs. And we're working hard to try and make sure that will survive across time. And then it has all these amazing tools to do sorter comparisons and visualizations on top. So if you want to know more about just kind of starting Spike Interface and making a basic pipeline, there's an Introduction to Spike Interface course, which is at tinyurl.com/intro to SI. It's like 6 10-minute videos, and it goes right from installing Python in virtual environments to I have a working Spike sorting pipeline. And again, this, along with loads of other links, are in this SI Talk Resources page there. Okay, that's about the first half of the talk, which is just trying to sell the kind of basic and kind of give the philosophy of Spike interface to you. And the second half will be some kind of more niche advanced features. So if anyone has any questions, that would be a good time.
I tried with the some recording data to Spike sort, like use the Spike interface, but I didn't make it work because I don't know, I have to convert to another format or
Sorry, you wanted to convert to another format, or the initial recording format you couldn't load, or?
we had a recording with the Plexon like 5 years ago, so they asked me to use that file. And I tried to use the Plexon like PLX file, but for me it didn't work, so I had to convert to another format. So
Great. Yeah, that's sad. Um, I don't know exactly what we like. I'm not an expert. Supposedly, we do support some Plexin formats, but as you're saying, these formats change over time, and it can be that it doesn't work. The actual thing that deals with all these formats is a package called Python Neo, which there's quite a lot of crossover between the developers. So maybe you did this, but I'd recommend finding the Python Neo GitHub page and starting an issue just to ask about it. And it might be that nothing will come of that, but that's would be my advice, if something like that happens.
okay, thank you.
So I'm sad to hear that, but
Any other? Yeah, one more.
If there's a way to do quick quality checks of the spiking data with this interface,
yeah, like the output of a sorting.
or I guess you already showed that. Never mind.
Yeah, I'm going to show that in also some more detail as well. So that's great.
Okay, great.
Yeah, what we're slightly lacking is how to check recording quality, which I think everyone doesn't really know how to check. But I think that's a fun project for anyone thinking. Okay, I'll now show you some cool features of Spike Interface that are meant to make your life a little easier. And just to say, I have some code ready which can go through any of these features. So if anybody wants to see any of these in action, we can. So one thing is that Spike Interface can visualize raw data. And it's quite cool because this is a heat map of the electrical series. And when you see blue and then red, that's an actual spike that you're seeing from raw data. And the reason it can do this is that all of our data loading is lazy. So when you load in an 100 gigabyte file, you don't actually load in the file. And then you only load it in when you kind of ask for it. So when you ask for this second of information, then it loads. So it's just quite cool that you can visualize raw data easily. And talking about large files, so NeuroPixel 2 data sets, you're looking at about 80 gigabytes per hour. If you have 100 recordings, it starts to cost quite a lot of money to store them. But there's this paper, a year or two ago, which suggested you could use audio compression, lossless audio compression, to compress these files. And using this, you can compress a NeuroPixel 2 recording down to about 40% of its original size. And you can do that by simply loading the recording in Spike Interface and saving it using the ZAR format. Cool. You might have also heard about drift problems. So if you have an acute implant, as your animal, as the subject is moving around, the probe can move around. And this is what happens. So this is a data set from Nick where he deliberately moved the probe around, I think. And these are spike locations over time. And spike sorters have a problem like this, about this, because if your probe is moving, the electrical signal you're getting from neurons changes. And so the templates, which represent the electrical signals, change. And spike sorters use these templates to do their clustering. So if your template changes because your probe is moving, the spike sorters start to fail because they can't cluster accurately. So that's a problem. But luckily, some smart people have thought about some algorithms to try and help this. So for instance, there's a dredge and medicine and what's it called? Kriging or something, which is in kilosort. And using spike interface, you can try and correct for this motion on your raw recording. So it goes from on the left here is the raw recording, and then on the right is the recording with the motion corrected. And the nice thing is again, it's a one-liner in spike interface, but it also outputs a motion object that allows you to visualize these things. And so you can get an idea of, well, for my data, is dredge the best, or is medicine better, or try out different bits and pieces. So that's cool. Also on pre-processing, we've just added something where, okay, when you go and you talk to a colleague or you speak to someone from another lab and you ask them about their spike sorting pipeline, maybe, and they tell you about all their different pre-processing steps. Well, instead of doing that now, you can get them to send you a sorting analyzer, and from the sorting analyzer, get the pre-processing steps from it easily in like a human readable form. And then once you have these pre-processing steps in a dictionary, you can apply those steps to your own data. So to be able to use, say, the Allen Institute's pre-processing pipeline on your own data, all you've got to do is ask them for this dictionary or ask them for a sorting analyzer and extract this dictionary from it. So this should hopefully be able to make like pipeline sharing easier between labs. Okay, great. That's all the kind of fun pre-processing tools. The fun thing with spike sorters is that we've containerized all the sorters. So containers, you can think of them as kind of isolated applications that have everything installed in them already. And then if you can get something like Docker working, you can spin up one of these containers and all the software you need is already inside it. And importantly, those also include MATLAB-based applications, so MATLAB-based sorters. And the nice thing about them is that you don't need to pay for MATLAB to use them. It's all legal, but you don't need to pay for a MATLAB license to be able to use a MATLAB sorter, which is pre-installed in one of these container applications. So that's nice as well. Okay, looking at post-processing and the question about the quality of units. So I think your next talk is going to be about quality metrics from sorters. And in Spike Interface, there's about 40 quality metrics. So these are simple things like signal to noise ratio or ISI violation rates. So how many times the interspike interval is violated. And again, with the analyzer, you just take your sorting analyzer and compute the quality metrics. It'll automatically compute all of them that it can, again, about 40. And then you could curate your units by doing some simple thresholding. So something like just take units where the signal to noise ratio is greater than 2 and the ISI violations are below some number. That's one approach. There's another approach. Recently, there's a preprint from a few months ago called unit refine. And the idea here is that the Moozle lab curated about 3,000 neuropixel units that were sorted by kilosort. Anushka really spearheaded this effort. And then they trained a model which can curate units based on those quality metrics. And it was also shown to generalize, fairly well across different brain areas and different species. And the model is just on Hugging Face Hub, which is a repository of like kind of ML models and things. And you can apply it to your sorting analyzer using one function, and you just need to give it the Hugging Face Hub repo ID, and it will apply that model to your data. Or you can create your own curated model. So the idea here is you maybe have 100 days. You manually curate like 4 of them, say. You train a model based on your own curation, and then you apply that model to your other 96 days. And so you don't have to do so much manual curation. And you can do that easily in Spike Interface. You just give it a few analyzers, give it your labels, and then you can apply this model to your other analyzers. So those are two different approaches, a simpler thresholding approach or an ML approach to unit curation. And then the last thing I'm going to mention today is a sorting view, which is similar to the Spike Interface GUI that I showed earlier, apart from it's a cloud-based visualization. So when you say plot sorting summary, it actually generates like a URL that you can go to, or you could send that URL to some colleague across the world, and then they can look at your outputs and they can see what the sorting is like. So those are just some fun little features of Spike Interface. Just to say thanks to everyone. There's quite a big community around Spike Interface. Alessio and Sam are the lead developers. There's a bunch of core developers who it's some part of their job to work on Spike Interface, and we're coming up to 100 people who have submitted PRs to improve Spike Interface. So that's great. We're always trying to apply for funding to get more people involved. And one annoying thing about funding is we have to prove we're popular. So if you use Spike Interface, or if you like Spike Interface, if you can go to the GitHub page and give us a star, it's very much appreciated. It's a bit corny, but that's okay. And yet, also from the Spike Interface page is all these docs that contain way more information about what I've discussed today. And if you have any particular questions, feel free to get in touch with me. My email address is on the screen. Okay, that's me.
Thanks, Chris. That was great. Do you have a couple minutes to answer other
Yeah,
questions?
yeah, absolutely.
Okay. Any other questions? Yeah, here.
It's a naive question, because I've just used like the fill sort GUI, but if you have like different probe designs and you want to input different probe files into Spike Interface, how do you hand it off to the Spike sorter?
Yep, absolutely. So yeah, there's lots of different ways you can give it probe information. So something like OpenEFIS or SpikeGLX, those formats contain all the probe information in the recording file, so you don't have to do anything. The probe is just automatically there by default. Actually, I can even show that. But then alternatively, people like Cambridge Neurotech, they keep a library of probes, and you just need to give it the manufacturer name and probe name, and then you can get those probes. Or you can use some sort of probe, standardized JSON file or something. So there's a few different ways to insert probes, but there are lots and lots of different ways. These are actually pretty well covered in the Intro to Spike Interface course. In the second one, in the second video, it goes over 4 different ways to attach probes to your data. So I'd recommend looking at that. But I can't resist if we take in a recording. So this is an OpenEFIS recording. Whoops. Then the probe is automatically attached to the recording, and we can visualize it immediately. Cool.
Any last question? Yeah, one more.
So you concatenate files from I don't know, weeks apart. How good is the solution correction? How good?
Okay, can you get a question? The question is about if you concatenate files that have a long time delay, like weeks apart, can the motion correction handle that, or how good is the chronic situation? Yeah.
Yeah, good question. I've never tried weeks apart. I've tried days apart, and it does okay. What I found in general for chronic is that motion correction is just basically not needed, and that when you're looking at 2 chronic recordings that are weeks apart, you're trying to find an overall one number to describe the shift between them. But anyway, certainly days apart yeah, it works great.
Yeah, I think the papers about these different motion correction algorithms like Dredge and the Killsort 2.5 version have their own sort of quantifications of how well that works. And
Yeah, but most of that work is about like I feel like most of the work is reasonably short time scale motion, and you're trying to like track motion across time. And there's maybe not been that much about chronic, where if you're doing chronic weeks apart, yeah, you're expecting kind of one shift between the two sessions, maybe.
yeah, great. Chris, this was fantastic, and I'll add my own personal thanks to you because my lab used to, run Kilosort in sort of directly, but everybody has switched over to using Spike Interface because it's so seamless and such a nice piece of software. So thank you so much for your work on developing this.
That's great. Yeah, my pleasure. My pleasure to be here. So thanks, Nick.
Thanks, Chris. Bye.
Enjoy the rest of the workshop. Bye.